Excellent, Mr. Smithers. Okay, we're going nuclear today. All right, so it's, it's chapter 10, and let's just orient ourselves on the course briefly into the 101 shell. Here's the syllabus. So I'll just let you know where you are. A few people said they need more time on exam 4. That's fine. You know, I don't have a problem. That the schedule is there, and another thing I really want to mention is I've got a lot of people that have not turned summary 1 in yet. Like, I mean, over half the class, but just barely over half the class has turned in summary 1. So
I turned in summary
planning to at this point.
I mean, if you're dropping the course, just go ahead and drop the course. But you can't.
I did summary
You
1.
can't get a full grade if you don't turn your work in. So you got to turn
Summary
something.
2, I haven't gotten a reply or a response to any of it. And it's
I have
been-
graded all of the summary 1s and summary 2s that have been turned in. So if you
Oh,
think you've turned it in,
I know I did, yeah.
Yeah, I've got grades.
okay. So I mean, I go right into the website. It says these still need to be graded. I grade them. I get it down to 0.
Mine, chapter, or summary 2 is 11 days old now,
Oh.
or 12 today.
I graded everything. What is
I
it?
have-
Tuesday. I
I
graded
have
everything
everything
on
done,
Sunday
like,
night.
through exam 4, I did exam 4 last
Good.
night.
Yeah, good.
But problem set 1, I still haven't handed it in to you,
Mm-hmm.
just because I did it all on paper, and I don't know, how to go about uploading it.
Okay, so the question is, if you did it all on paper and you want to upload it, you can take a picture with your phone and turn it in as a JPEG, or you can take it over to the UC and have them scan it onto a zip drive or, a thumb drive and upload it that way.
Okay, is that just in the little office downstairs?
Yeah, there's it probably costs you $0.25 to scan
Okay.
your homework, yeah.
Okay, that was probably what I'll do, actually.
Yeah. So, as of today, all of these things are due, up through summary 3. And this week, you'll start working on summary 4.
And that'll be due before we go up.
Okay.
Exactly. Yeah,
Thank you for doing this.
absolutely. Yeah, so summary 3 is due. Well, it's past due at this point. Like I said, it usually takes a little more time than some of the others. But, at this point, you should be finished with summary 3, with exam 4, with the first problem set. I think everyone's done all these other exams. There's also a couple people, or, few people who haven't turned in summary 1 or summary 2 yet. So if you're still confused by that, the submission portals are right here. I think summary 1 was,
And thanks for giving us 3 chances on this last one.
sure. Upload summary 1 right there in week 3.
Yeah, there's 3 chances on this last one.
No.
I still only did 2.
I don't know why there was 3. That was probably a mistake, but if it was there, have at it. Take advantage.
Oh, I
Take
did.
full
Yeah, I
advantage.
only did 2. I only thought to look for, I don't think I needed the third one.
If you need a third one, that's okay.
There's summary 2.
And then upload summary 2 right here. So there it is.
Can you
Go
click
ahead.
on summary 2 form, see if I am actually on it there, please?
Mhm.
There I am. 14 days ago.
Is that the
Um,
one?
Yeah.
Did you submit it to the submission form too, instead of just the form? 'Cause you have to
I think that's probably what I did. That's what I did then, I guess. I just did it.
You have to upload it here and here.
I did it just to the one, so that's the problem.
Okay, yeah.
The form is for peer review, and this is for grading.
Okay, so since you saw that I did it 14 days ago, is there if I just flip that over this afternoon?
Well, you have to, otherwise I can't grade it.
Okay, good. I was just hoping that you graded.
I will grade it, yeah.
Good. Thank you.
When you drop something in the module like that, it notifies you, right?
Oh, yeah.
You have an assignment
Yeah.
that needs attention.
Yeah. I just, I click on the, I'll click it here. Let's see, week 2.
So that's what I did. I put it in the form instead of the actual upload.
happens. Okay, let me just find summary 2. Upload summary 2 here. 2, receive a grade. How's that?
Cool.
Yeah, the form just for discussion. So needs grading 0. There's nothing in my inbox for summary
I
2.
fully gotcha. It is my,
And then you said you're gonna go over, summary 3.
I will. I'm going to wait for Taylor to get here. So let's just get into the chapter a little bit. Okay, so this is chapter 10, nuclear. And this is, just kind of the history of it and some of the physics. And I know we talked a little bit about peak oil a couple weeks ago, and one might look at this and say, oh, maybe we've reached peak uranium. Right? I mean, you might look at that and say that. That's not necessarily the case. It has happened in a few places. We haven't really mined every single place on planet Earth for uranium, but you can see, what year is that? Maybe 2005. The amount of terawatt hours peaked. And you can also see it's just gone down as a percentage too. Other fuels have come online, natural gas being one. Renewables are partially responsible for that. And let's just do some quick math here. Turn that 3,000 terawatt hours into joules for me, would you? Let's just do that as a little wake up. See if I can do it. Let's stop the recording and. So let's just do that really quick as a class to know how to do this. Because, if you're, let's say, doing an energy audit for somebody and trying to decide if they should, go off electric heat and go to gas heat, and the gas is measured in BTUs and the electricity is measured in kilowatt hours. I mean, it is critical that an energy technologist knows how to do this. It's critical that an energy scientist knows how to do this. I mean, you have to be able to convert between units of energy. I mean, it's a fundamental requirement. So let me show you how I got there. So we started out with this little graph, and we were showing that right around 2005, global nuclear electricity. This is electricity. This is not heat. I mean, this is using nuclear energy to make steam, to make spin turbines to make electricity. So it was close to 3,000 terawatt hours. That's obviously a measurement of energy, not power. And so what I asked you to do is convert that terawatt hours into joules, because we know that a watt second is a joule. You don't have to get quite that nitty-gritty. We just do a little conversion. So this is the question. 3,000 terawatt hours into joules is the question. So here's the answer. I went ahead and just wrote 3,000 terawatt hours as 3,000. Tera turned into 10 to the 12th, and watt hours just stayed as watt hours. I then went ahead and converted that into kilowatt hours, because that's something that we typically work with. That's what you see on your energy bill. It's the easiest conversion for me to typically make. So we talked about the fact that 10 megajoules is one human metabolic day. A house runs at about a kilowatt, so a home consumes about 24 kilowatt hours a day. So they're just kind of easy numbers to work with. So, again, this is just the original number. 3,000 times 10 to the 9th kilowatt hour is the same as 3,000 terawatt hours. Because this is a 9, and that's a 3. And when you multiply 9 by 3, well, when you multiply 10 to the 9th times 10 to the 3rd, you get 10 to the 12th. Just regular old exponential math. Okay, now, this is the conversion right here. I know that in 1 kilowatt hour, and we've done this numerous times in this class now, I know that 1 kilowatt hour is 3.6 megajoules. So if Kat were here, I would ask her, I would say, Kat, what's 3.6 megajoules divided by 1 kilowatt hour? What's that equal? And what'd she say?
1.
It equals 1. Yeah, I'm multiplying by 1. Because it's just a units conversion. So 3.6 megajoules, big M, megajoules, divided by 1. So that's just by 1. So now, what I get to have happen is the kilowatt hours vanish. Oh, and let me just make a little correction here. Need an equals sign there. Equals. So all I'm doing is multiplying it. If you're more comfortable writing it like this, you can put your parens in there. If you're more comfortable with the multiplication, you can put a star or a dot or an X or whatever you like. That's just how I write it out there. So when I multiply 3,000 by 3.6, I get 10,800. And the 10 to the 9th just stays as it is, and the megajoules survive right there. So again, we talked about every one of these problems, kind of 3 problems at once. There's your arithmetic, there's your powers, and there's your units. Any questions on that? Okay. And now, this is a little clunky, so I just took this 10,800 times 10 to the 9th, brought it down here. So it's 10.8 times 10 to the 12th megajoules, which is the same as 10.8 times 10 to the 18th joules. And I just wrote this out for myself. I know kil is 3, I know mega is 6, I know gig is 9, I know tera is 12, I know peta is 15, I know exa is 18. So now I can just take this number and write 10.8 exajoules. Now in the back, I heard Tim say that he got 1.08 times 10 to the 19th joules, which is also correct. Now, another important point here. Both of these are correct. One of them is scientific notation, and the other one's engineering notation. Which is which?
Scientific's the bottom one.
Yeah, this is scientific, and this is engineering. Engineering, typically, you're only going to deal with no more than 3 significant digits to the left of the decimal. Once you hit 4 sig digs, like you would typically write this as 3. What would that be? Petawatt hours. Kind of a weird number, but that would be the engineering expression of that. This would be 3 petawatt hours in engineering notation. Okay, clear on that? Yeah.
So the question you asked, how did I do that without a piece of paper? Remember I told you week 1 or week
Oh.
2, find one of those conversion calculators that makes you happy, whichever one it is. Literally before you even got your piece of paper and pencil out, I already had the answer. Just make it as a free app on your own.
Yeah.
Trust me, you will be doing this enough that you need to know how to do it the way Brad did up here, but to double check yourself, have some
Yeah,
sort of
that
app or a little
yeah.
gadget.
Yeah.
I remember you talking about that app.
Yeah. What calculator do you have? Or is it just on your smartphone?
Yeah, that one was on my smartphone.
Yeah.
Let me see which one that was.
I'll write this down. Is this a good one that you like to use?
Say again?
Is this a good one that you like to use, that you're confident with, that app?
Yeah, it's convertmeasurementsunits.com.
Convertunitsmeasurements.com?
Yeah. It depends. I've got one that's just tabbed on my laptop that I use all the time. Just
Tab, yeah,
to
yeah.
it.
There's a bunch of them.
Yeah.
Oh, okay, I got, cool.
And that, you know, that one's pretty simple.
Engineers, try to work.
They're not all the same. Not all engineers are bad.
Trying to
Come
work
on.
with them out in the field is a headache.
So, you know, here's another one, just kind of
I like the engineering.
fun, yeah. Engineering unit converter.
Oh, cool.
So find one that's not too over the top, you know, so that's, I guess that's the point there. Okay, so, there you go, a little wake-up math. And let me just, I'll pause it there so I don't get the recording going too long. Get into the chapter.